Welcome to Coding Adventures. Today we're continuing the discussion about objects and functions, and we're gonna discuss about how to place functions inside objects. So let's get started. Alright, so I'm back and I'm here on my desktop and I'm gonna start the code editor. And the first exercise that I'm gonna do in this code editor, I'm gonna create a very small inline object with the syntax that we already know and we learned in a couple of lessons ago. So let's create perhaps a small bubble object. I'm gonna just use let bubble and use the curly bracket syntax to define this object. And as properties for this object, so again we want to create a small bubble which is basically a small circle on the canvas. So inside this object we're going to define a few properties for the bubble, perhaps the x coordinate, and let's choose a random value, and the y coordinate, and also choose a random value for this coordinate. Just like this, right? Now if we want to display this small object, let's create a visualization function here, call it display, and we're gonna basically inside we're gonna just use a circle instruction that we're gonna take the x coordinate from the bubble object and the y coordinate and use a certain radius, perhaps 5, to display a circle. And if we run the program, oops, we have to call the display function first. You can call it somewhere here. If we call this program, we should see a small circle, and each time we are running it, we should see a small circle in a different position. So yeah, let's define also the radius r here, just not to have it hard coded like a number inside the program here. And now let's see how can we make this small bubble that appears here on the screen move around and bounce from the edges of the screen. And we created this exercise many times again in the past, and we'll create it again today. But of course we're gonna use new kind of features of JavaScript this time. But we'll take it baby steps, all right? So the way we usually make this kind of bubble move, we basically have some dx and dy variables representing delta x or delta y, or velocity on x on x-axis and y-axis, and then we are adding this to the actual position, right? So let's also define a couple more properties inside the object, like perhaps we should define speed. We have already this x and y here coordinates, and let's define also this dx, which should be a random between -1 and 1. And again, this delta x and delta y, they have actually the meaning of more of a direction, since they have only they are limited to values -1 and 1. But in order to actually create a movement on the horizontal axis, we're gonna multiply this dx with the speed to basically control that, how fast the bubble is moving. So, and we'll have also a dy, same kind of random formula. All right. So at this moment here we have a small object of properties. Of course, this object has only some numbers inside. It's not doing anything if we are not writing the logic now to somehow animate it and display the different coordinates on the screen. So let's do exactly that one. We're gonna create a function loop, which is basically essentially if we want to create this kind of animations. We're gonna invoke first clear, and then we're gonna invoke the display here. And this is not enough. If we do just this, the bubble sits in one spot, because we are actually not updating these coordinates. So let's now implement also the function update. And inside this function, we plan to basically, of course, we're gonna call it from the loop. And inside this function, we plan to modify the coordinates of the bubble x and bubble y by adding this dx and dy kind of values to it. All right, so let's do just that. Bubble x, we are adding to it the bubble dot dx. And as a matter of fact, we said that we're gonna use speed as a multiplier to increase or decrease the speed, since we are limiting the dx and dy values just to -1 and 1. All right, and we are doing the same for the other direction. .dy, and let's run it just to see it. Of course, it's not complete. Oops, speed is not defined. All right, yes, here we should also say bubble.speed, just like this. Since these are basically properties inside this object, well, they behave like general purpose variables, but in order to use them, we have to refer them via the object that contains them. So that's why we are saying bubble dot. Please refer to the 2 lessons ago when we discussed about objects. So let's run it again. The bubble runs and goes outside of the screen at a high speed. We have to now implement those conditions to check if the bubble hits one of the edges of the screen, and if yes, we invert the direction. So let's do that really quick. So if bubble.ex, this is on horizontal. If it's less than 0, tries to go outside from the left edge, or if bubble.x it's greater than 800, tries to go out on the right edge of the screen, then bubble.dx, we multiply this by -1. We're just inverting the direction on horizontal. And let's do the same one with basically the y-axis. The difference is that we have 600 pixels on vertical here, and here it should be dy. All right, so if we run this one, we should have a pretty happy bubble that bounces on the screen. As you can see, goes back and forth, and we can just watch it. We can replace the bubble perhaps with any other better rendering if we prefer that, but that's not the point. Anyway, up until now, this exercise is pretty simple, and it's exactly probably like the exercise that we did a couple of lessons ago. But now, let's look a little bit at how the code is structured. We see here on top this object, this inline object called bubble, and is defined using this inline syntax, using the curly brackets, and between the curly brackets, the object contains all its properties like speed, x, y, r, and so on, right? What we can see also are these functions, display and update. And these one are actually working on the object. As we can see, it tries to affect the state of the object. They manipulate x and r and so on and so forth. So because in a sense, we can see that these are coupled to the object itself. So let's see how can we actually take these 2 functions, display and update, and make them part of the object. So basically put them inside the object, right? And since this one are controlling the behavior of the object, in object-oriented programming, these kind of functions, when they are inside the object, they are sometimes called behaviors. Not to mention that other people, the technical term for this function, it's something that we're gonna learn when we discuss about classes. So let's see how we're gonna place this inside. For the moment, I just cut this and I'm gonna paste them here, but that won't be good. All we have to do is something that we learned yesterday. Since these functions can be taken in variables, we can very well define here some properties. Perhaps we should call this one display, and this one should have as value this function, perhaps, right? Like this. Let me ident them a little bit. And of course can be an anonymous function. This is how we saw yesterday that we can basically define a function and take it in a variable. So therefore we can do the same and put it inside the property of the object here. So let's do the same with the second one. We should have another variable or another property of the object update here, that it's of type function and has all this body. Let's ident also a little bit the body so we can see it more clear. Just like this. All right. So we kind of took from outside the display and update and placed them inside the object. On the outside, we only have right now the loop function. If we'll try to run it right now, probably won't work, for sure won't work. Display and update, for instance, here they refer some function that they no longer exist, but we know that they exist inside the object. So let's try to refer them via the object, bubble.display and bubble.update. And let's run it in the state that it's right now and see the effect basically. Right, the bubble is still moving, and basically we did something good, right? There is one thing though that we want to modify here. Notice if we want to rename this one bubble2, all right, so we're going to change all the references, bubble2, right? But if we run it, will not work. And the reason is, let's make it back bubble, is because this bubble object is also referred from inside. And since we are inside the object, JavaScript put at our disposal a very nice way to refer to the current object, so to the object where we are inside. And this is basically, instead of saying bubble.x, we just say this.x. This is a reserved keyword in JavaScript that allows us basically in this particular case to refer to this the current object where we are inside. And this is very nice because we can basically rename the object on the outside, we can take it in different variables, but this will still work because we'll refer to the current object. And this is a very, very troublesome keyword in JavaScript. Let's run it. It's running just fine. But as I said, when we're gonna work with this, most cases will work, but you'll encounter some weird situations where it's not working. And at that point, we'll not then discuss right now those situations, but I encourage you to research further why it's not working. Because the reason being this has a more complex behavior than what we are showing here. Anyway, for the purpose of the exercise, what we accomplish here, we took a plain object that contained only properties like numbers and strings, but in this case numbers, and we added also some behaviors inside, basically some functions. In our case, we added display and update as anonymous functions inside. And the other thing that we noticed, that we modified, we made use of the this keyword in JavaScript to refer to other properties within the same object. All right, it looks pretty okay right now. If we collapse this one, we'll see that our entire program is composed of an object and a function loop, which basically it's everything we need to make it run. All right, let me save this program right now, and maybe I should call it bubble1 because you may probably hint I'm trying to extend this program a little bit, and I'm gonna place this one on the chat. Bubble1. All right, the program is on the chat now. So when we are looking here at this program, let's see how can we extend this one to have more than one bubble, to have multiple bubbles going around on the screen and bouncing from the edges. And obviously one solution, for instance, if we have two bubbles, is we copy and paste this one and have a second kind of bubble here, but that will be messy. First of all, we'll have so much duplicated code. The other problem is that, well, we can just copy and paste so many bubbles. So obviously we need to produce this kind of code in a dynamic way. So there are multiple ways to do it. One way in which we can do is basically, let's create a function here, create bubble. And this function will be a factory, basically, will create bubbles, or just one bubble in this case. And what we're gonna do, we'll take all this code. So we just took the entire bubble object, we are placing inside the function, perhaps, yeah, like that. Let's ident this one more time, like this. So we have now the bubble inside the create bubble function, and what we're gonna do here, we're gonna return it, right? So we have it like an object, and then we are returning it. We can return it directly from here if we want. We can just write return if we prefer, but for now let's leave it like this. Let bubble and then return bubble before we are ending the function. And now with this function, what we can do is basically define again let bubble. This time we are using a this variable is different than the one inside. This is a local variable for the function. This one is a global one that we basically use. And we are using this global one so both functions, so also the loop function can access it and manipulate it, right? So the code is right now the same as before. The only thing is that we have this function that generates the bubble. So let's run it. Let me save it as a bubble2, actually, this one, not to override the first one. Let's run it. And yep, it's still running as expected. Baby steps, as we said, right? So let me put this one on the chat, and we are almost there. We just have now to fabricate more bubbles. That will be in step number 3. So this is bubble2. And now, with this function created here, it becomes pretty easy to generate more bubbles. So let's create another factory function that will generate more bubbles. Let's have a function, create bubbles. And maybe we should create n bubbles. And we're gonna use a for loop structure just to iterate, and then inside we're gonna invoke the create bubble function. So let's have a variable I, 0, I less than n, I plus plus. Let's put this in a temporary array that we're gonna return it here. And here we're gonna just say ar.push create bubble. And if you're not comfortable with having this syntax imbricated, we can take it in a separate variable. Let bubble equal create bubble, and then we are pushing bubble here. All right, so we have this function now that creates multiple bubbles, and instead of just calling the first one here to create one bubble, we can say let bubbles, let's have it plural, say create bubbles. Basically we are invoking this one, and let's create 10 bubbles, right? That's fine for now. All we have to do right now is basically, this one won't work. We can place a for loop in here for now, for let bubble of bubbles, and basically we have to invoke display and update for all the bubbles, just like this, right? So this is program number 3. We didn't save the copy. This is bubble 3, and let's save it, run it, and we have multiple bubbles bouncing from the screen, exactly like what we intended, right? We can vary them the radius if we want, we can vary them the color, and so on. If we can make them bigger, look better, we can put them colors. Let's add the color really quick here, because we like colored things. Color, and this is basically you can use the color function just to assign a color. This one is a property inside, and this is a function, and that basically returns a color. We used this one before. Let's have a random color, basically random R, random G, and random blue. So we have this color here. All we have to do is, before actually drawing the circle, to have a fill with this dot color. We have to fill it, and if we run it, we have colored bubbles bouncing on the screen. All right, let me share this program with you on the chat as well. This one is bubble stream, and the program is there on the chat. So let's inspect again the code here, and the new thing that it's basically in this exercise, it's the addition of functions here inside the object. All right, all the other things, the logic and so on, we just created here as a practice, and also, you know, just to create a nice practical example around this kind of object and see what is possible to do with it. Okay, perhaps we should do a little bit more complex example this time, and practice a little bit more with these functions. All right, So perhaps we should create a mini game. I'm thinking, looking at these bubbles, I'm thinking that maybe we should create a mini game. Let's see, it's totally unscripted. Let's see if we can basically achieve what we want to do. I'm thinking of a small Pong game, or similar to Pong. I don't think we'll have the time to do the Pong game, but similar to that. So let's start from this bubble that we just created in bubble 1 exercise. I'm copying here. Actually, let me copy it entirely and start from this program. It's just one single bubble. All right. Perhaps I should make it a little bit bigger from the beginning. All right. And now, of course, we should have a paddle here, and you know, the ball, if it hits only the paddle here, will basically be able to bounce back. Otherwise, we'll go outside and we'll lose a point or something like that, right? So we revert kind of at the beginning. We have the bubble defined as an object here on the outside, and what we're gonna do right now, we're gonna define also a paddle. So let's put the paddle first. Paddle. It's an object as well. Paddle, it's that we can represent it via a small rectangle. So the paddle should also have an X, which is basically, let's start with X as being 400. Somewhere in the middle of the screen. It's not quite middle though, if we have also width. A Y, perhaps 550, somewhere towards the bottom. A width 100, and a height perhaps 20 pixels, right? So it's actually, if we make it here at 350, I think will be middle of the screen. Anyway, something like that, right? And let's also have inside this paddle object also a display. That its function. And we're gonna write the code and put a comma. We need to put a comma here and not semicolon because we are still inside the object, and see how we have the other property separated with comma. So even this one is a big chunkier property because of the function body. We still have to remember after we close the curly bracket to put there the comma. And let's have just also an update just to have it ready. Function. And you know, we'll put here. So let's display it first. It's very simple to display it. We're gonna use a rectangle that is basically this dot x and this dot y, and width is this dot w and this dot h. We should not forget this dot here. These are not plain variables outside. So the pedal is fine. Now in order to see it, we have to go here, and we basically have to say paddle.display, and perhaps we should group the displays together, and perhaps we should have paddle.update just to call it. We don't have anything inside, but doesn't hurt to have it called here. And if we run now the program, well, we have a paddle indeed. And the paddle, it's stationary. Let's make it move using the arrow keys, and it's just a good thing that we added this update method, because we can go inside this update method and basically check for the keys, and if the left key is moved, we basically make the paddle go to the left, and if it's the right key, we make it go to the right. We can also have a speed here, like in the case of the ball. Oh, this is this one is not a bubble anymore. Let's rename this one ball. And here we'll just say ball. Just like that. All right. So it's still running, and even if we rename it, this dot still refers to the right object. So let's go inside here, and basically, in order to check for the keyboard, we can also get a look here under user input, and we look at this function key is down basically. So this is what we're gonna do. If key is down, left arrow, else if key is down, right arrow. So this is the thing we're gonna do. All right, we can even copy this small snippet. So let's go inside. The only difference, we are calling it from inside this update. In the example there was called from within the loop, but here we are still inside the loop. The loop function is calling the update, therefore we are still inside this loop that is called 60 times per second. So we basically get a chance to verify for the keyboard here. So if its key is down here, what we can say is basically say this dot x minus equal this dot speed, and we can also say else if key is down, right arrow, this dot x plus equal this dot speed. All right, so let's test it. And indeed we can move the pedal. The ball is moving, the pedal is moving, but they don't interact one with each other. So let's see, how do we solve basically this interaction, and basically the pedal, the ball see if it hits the pedal, and basically only then to basically change the direction here, right? So first of all, going in the update here, the ball should bounce back only if it tries to go to the top edge. If it tries to go to the bottom edge, should not bounce back, or at least should not bounce back normally unless the pedal it's under the ball. All right, so we need to have access to the pedal in this function, but this function is inside the ball. So basically what we can do here is okay, let's remove this extra step. So it's bouncing only tries to go through the upper edge, but we can also check if this dot y, so this dot y means the ball y, if it's greater than, now we can make a reference to the pedal, but this is not a good practice to make a reference to the pedal to say if it's greater than pedal y here. And the reason it's not good is because, imagine this again, we do the same mental exercise as yesterday. Imagine that this one is a library function, and now we are or it's a library object, and now we are composing with this one. They don't know each other beforehand, right? So the way we're gonna do, we're gonna create a property on the ball, and we'll make the ball know about the pedal, right? So yeah, let's do that. So the ball should know about the pedal. Instead of accessing the pedal that is kind of a global, it should access its own internal property. So here somewhere, the ball should know about pedal. Perhaps we can have also the first property. We can name it pedal, and basically the value it's pedal. It looks a little bit funny. This pedal refers to the one outside. This one is the internal property of the ball. So when we're gonna say this dot pedal, we're gonna refer to this one, which actually refers to this one. So in the end, it's kind of the same. So this syntax is supported to have the same, the property name to have the same value, or the variable that we put here in the value to have the same name with the property name. So let's just use it like that. So here we can verify if this dot pedal, so if the ball tries to go outside of the pedal, well, for the moment, let's make sure that we are correct, and let's make the ball inverse direction, right? We have to also check if the pedal is under the ball. That's the next thing that we're gonna do, but let's run it for a second. And let's see, yep. So when the ball will kind of hit the pedal X will come back, which is correct. But right now, oops, and I close it by mistake. I'm reopen it again. And now, but it's not enough to have this check. We also have to say, and we also need to check if this dot X, which is basically the ball on horizontal, it's greater than or equal. So basically we have to check, all right, let's grab a little bit the notebook here and see what we want to check to better understand what we want to check here. So we have basically, of course, this is the canvas, right? And at one point here we have a paddle. Let's make it a big chunky paddle here. And the ball is coming from here towards the paddle and is trying to hit the paddle. And right now we have to check this thing. First of all, if the ball X, which is the horizontal coordinate, is between this point and this point, right? So basically if the pedal is under the ball. So this coordinate is the pedal x, pedal.x, and this one is pedal.x plus pedal.width, right? Because we know the pedal width. So the ball x needs to be between these two values. And also when we are checking for the vertical, the ball y, so this says bx and by, so the ball x and ball y needs basically to try to go through the pedal, so should be bigger than pedal.y or equal to pedal.y. All right, so this is what we're gonna try to check in the code there. So let's go back in the code, and we're gonna say if this.pedal.y and if pedal this.x, we're still inside the ball, right? So this.x means the ball. So the ball x is greater than this.pedal dot double dot dot x, and this.x is less or equal than this.pedal dot x plus this.pedal dot w. All right, I think I wrote it correctly, but we can check really quickly here. Oops, the ball went outside and we didn't get the chance to hit it. Boom, and it's fine. There's only one small that we can adjust for, is for the ball radius. You can see that the ball kind of tries to go inside the pedal a little bit, so we can adjust for that one. So basically here, if this.y is greater than pedal.y minus this.r, right? Right, I think we are right. But we can test, because this.r is the radius of the ball. Yes, and now it seems that the ball is just hitting the pedal on top and not goes halfway to the pedal. All right, so in these situations, basically, we also change the direction. What we should do here, it's also a little bit of a correction that we also implemented last time, if you remember, when we did this exercise, but without objects, is basically to kind of reset the y position of the ball to basically, yeah, so to basically reset it to the pedal y. And this is because sometimes the ball tunnels a little bit to the pedal, perhaps comes at different speed, and will go a little bit inside and is not good. So we want to make it jump at the surface of the pedal here. All right, so oops, that was kind of a very edgy situation. Probably we just hit exactly at that. Nope, always that. Let's see. So this.y is this.pedal. Oh, yeah, we should make it jump at this one, not exactly like on the surface of the pedal. Let's run it again, and let's try to hit it. Come on, ball. All right, we're in good shape here. Let's see. All right. So yeah, so this basically verifies if we are hitting this this particular ball and goes back. So at this point, you know, let's name this one kind of pong. It's not kind of, it's not pong, it's ping pong. Ping pong, I don't know, something like that. Anyway, let's see it again, and let's see how we can extend this mini game and also make use more of these properties. All right, I know, I have an idea. Let's add another pedal at the top, similar to how we intended to do last time when we didn't get the chance to do it. So let's have a pedal too, and also give us the opportunity to see how it solves this challenge. One ball is fine, we can have it here, we can write all the logic inside, but we have just one pedal, yes, we have one pedal, and if we want a second pedal, we have to basically duplicate the entire thing, or we can do what we did in the previous exercise and create a function that will return this one So we're going to invoke it twice to create the first pedal and create the second pedal. So let's do that. So we're going to wrap the pedal, this entire thing, which is a lot, inside the function that will return the object. And, you know, just for consistency, we're going to wrap also the ball inside the function. So we'll have two functions here, one that returns the ball and one that returns the pedal. The difference is that we're going to create two pedals, but we'll keep one ball. All right, so let's do that really quick. Function create pedal, and we're going to wrap the entire thing we said. So I'm just taking this one very carefully. No more, no less. We have to take the entire thing and place it inside. And yeah, we can, you know what, we can also say here return, like we said that we can do basically. So let's return this one. We're gonna look again at the function. Looks a lot of things in one return statement, but if we look closely, the curly brackets should open and close as they should be, so everything should be fine. The way to test it, well, we can go outside and have it the same statement here, pedal equal create pedal, like this. And if we run it, yes, the program still runs, so it's fine. And we'll come back on this one because we have to create two pedals, but let's wrap really quickly also the one with the ball here. So we're gonna have function create ball, and we're gonna take the entire code up until loop, we delete it and paste it inside, just like this. And let's indent it a little bit, just to look a little bit nicer. And we can do the same thing here, basically return this object directly. So looks fine. All the curly brackets are opening and closing correctly. So let's have it as well here as well. We can have let ball equal create ball. All right, now if we'll just run it, it's running fine. That's not a problem. But let's now, well, let me save this one. And actually I'm gonna share it just right now with you on the chat. And remember to, if you are opening it on your side, remember just to reload it from time to time because we're gonna add code and save it. All right, so this is ping pong, kind of. And now let's modify the program a little bit, because first of all, the pedal, since we are creating two pedals, we need to specify they'll have a different Y position. So perhaps the pedal should take a Y argument here. So instead of 550, should be a Y. So we're gonna create the pedal at 550, right? So we parameterize the function. It takes this Y that comes in here. So we should have the same effect, right? And now let's also modify create ball, because see, ball is referring to that pedal global variable. We don't want that. We want, when we create the ball, we want to specify which is the pedal that we're gonna hit the ball. So it's basically we are passing it as parameter here. Create ball takes pedal as an argument. So basically create takes pedal as an argument, and now this pedal refers to this argument here because it's closer to it and not the global one. Remember the lesson about variable scoping. All right, so it looks a little bit nicer, although we still need to create one more pedal. So let's create this. So perhaps we should call this one not pedal. This is bottom pedal, or pedal 2, pedal 1, pedal 2, pedal bottom, pedal top. Yeah, pedal bottom, pedal bottom, and pedal top. Or top pedal and top bottom pedal. Yeah, top pedal and bottom pedal. All right, so these are our two pedals. So the one on the top should be somewhere at perhaps 30 coordinates, something like that. All right, pedal is not defined very well. If we go inside the loop here, we are trying to refer the pedal. So okay, let's do bottom pedal and top pedal, both of them, right? So this is bottom pedal, then we have also the top pedal, And the same for update, top pedal.update, and this thing is also bottom pedal. All right. So inside the loop, if we look really closely, we are first displaying the three entities, the ball, the bottom pedal, and the top pedal, and then we are updating them here. So looks kind of okay, okay-ish at least. So let's run it. Oh, pedal is not defined. And now where else can be pedal here? Huh. Create ball. Oh, right here. So create ball needs to know about two pedals. So perhaps should know about the bottom pedal and should know about the top pedal. Not only one, but two, right? So, okay, is moving. Of course, doesn't know about the one above to just hit it. So we have to take care of that one as well. But at least the two pedals are moving together when I'm basically using the right arrow and left arrow keys, which is good. Let's handle also the ball hitting the top pedal here. So we're gonna scroll inside the code here. Oh, first of all, we need also inside the code to have two pedals, right? Create ball. See, create ball, we have it with only one argument, but when we are invoking, we are passing two arguments. In this situation, basically just the first one is used. So basically we are referring as by pedal to the bottom pedal. So let's go here inside, and perhaps we should keep a reference to both. Actually, yeah, that's what we should do. We should have bottom pedal and top pedal also as internal properties inside here, and of course these ones will come as arguments to this function, right? So right now we are in good shape. We are passing both pedals. We store them as in here, but we need to modify here, right? Because when we are hitting, so yeah, so this is basically hitting the bottom pedal. Check bottom pedal. So we should just copy this text bottom pedal and replace here pedal, 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 and the last one as well, right? And then this is the, yeah, I think we should be in good shape. Let's run it. All right, the one on top still not reacts, which is normal, but the one on the bottom works perfectly. All right, now what we have to do, like we did with the bottom one, we should remove here also the condition. So if it's trying to go to the top edge, we should let the ball go outside, but of course we're should check if it hits the top pedal there. So it should change. Oh no, not here, here. So if it tries to go to the top edge, we basically should let it, we should change the direction only if there is a pedal underneath, and this is the other pedal. So if this dot y is less than 0 and there is a pedal there, right? So then this dot top pedal dot y actually is not the let's see again what will be the coordinates on that. So the ball on the here, we should check if the ball tries to go below this coordinate, not 0. So this one is basically top pedal x plus top pedal h, right? So here, if this dot h is less than this dot top pedal y plus this dot top pedal dot y plus oops, this top plus h here, right? And we're gonna check also if the pedal is in between. We just want to see if this is the right. So we just we should also take in consideration the ball radius. Let's run it again. Oops, come on. We have that weird situation that, yep, we should also take in consideration the ball radius when it tries to go on the outside. So here, if it's plus this.r. All right, something like this. Let's run it. It was an impossible game. All right, let's say it's okay. Nope, something is not right on with that one. No, it's kind of okay. Let's see again. Yeah, it's okay. We just have to reset the position basically to this one. So basically this.y becomes this expression. All right, let's run it again. It hits correctly. It looks like it's not hitting correctly, but I don't know. It's either it's a optical illusion. Now it hit correctly. So let's assume it is. If not, we're gonna fix the small glitch later on, right? All right, but still it's not working because we also need to check if the paddle is this.r whole thing, basically this expression. The only difference is that we have to check it for the top paddle. Well, here the good part is that we can write on the other line. We don't have to put the entire thing on a single line inside the if. Already the code is a little bit big for this one. And if this.x is bigger than, so if the top paddle, it's just under the ball, right? Or above the ball in this case. So, yeah, just like that. Now, check top paddle. What we can do, we can extract this one in some extra functions like paddle hit, and that will be the recommended way to do it. Perhaps we should extract them, but for now, let's continue with the exercise. Let's see. So if it goes to on the outside, okay, we lose the ball. Of course, we'll come back here if it reflects on the walls that are invisible. We can stop the game or something like that. But perhaps initially when the ball is starting, let's do like we did last time. Let's not make the ball just, appear in the middle of the screen and we have to rush to catch the ball. Let's start nicely with the ball, perhaps on the bottom paddle, and we're gonna press space. We're gonna launch the ball, right? So, and then, maybe we can make this a two-player game, right? And if and next time maybe the ball should start on the paddle of the other player, which is the top player. And basically in this case the ball should have three states, right? It's in motion, if it's on the bottom paddle, or it's on the top paddle, right? So let's include in the ball object here another property, and perhaps this one should be the state, and we can have it like a number, right? So okay, what can be this number? Can be 0, can be in motion, 1 bottom, 2 top, right? Something like that. So of course we have to make use of this this property now in the logic, and let's see how can we make use of this property. Right, so in here in update, this whole update is actually is actually good if the ball is in motion. If the ball is in motion, the update has total different rules. Has rules such as maybe the ball should sit on the pedal, and if the pedal moves, the ball is moving with the pedal, something like that. So the entire thing here, maybe you should call it, maybe you should create another function, update, an empty one, just like this, update. All right, why is not coloring it? All right, let's see. Oh, I didn't write it correctly. And this one, maybe it's update in motion, right? Our old update, I just rename it update in motion. But from inside here, let's call update in motion. And now, look, another new thing. Even if you're calling another function, as long as this function inside is the object, you cannot call it just like that, like we used to call functions until now. You have to prefix it with this dot, exactly like you prefix when you want to access properties of this object, right? So let's see if the code is still running. should run basically. All right, we are in good, it's fine, but we should call this function only if we are in state 0. So what we can do here, if we say if this dot state equals 0, then basically this is our update function, right? Else, for the other states, we should create another similar to this one, update on paddle. So we update the ball on paddle, which is a function, and the same, and perhaps we should specify on which paddle to call it. So anyway, let's take all the states. If this dot state equal 1, so basically it should be on the 1 means bottom paddle, right? So in this particular case, we should call update on paddle. Don't forget this dot, update on paddle. And let's pass actually on which paddle we want to update. We should put here a variable, an argument, right? So when we're gonna call it with this state 1, we already know we should update the ball on this particular paddle, and we're passing the paddle as an argument. So update on paddle, and this one should be this dot, I think it's called bottom paddle. Yep, bottom paddle. Paddle. And if we do the same thing, we can do also else if state equal to, which you can just put else, single here, else. And this one is update on paddle, the other paddle, these ones. Now let's run it. Oh, it's nothing different. Let's start actually, instead of state, where did you find the state? Somewhere. Yes, let's start with the state as being 1, being on the bottom paddle. So basically we should call directly in this function. And of course the ball is there, it's not moving because it just starts at that position and there's no update performed here. So what can we do? We can do like in the previous exercise. If it sits on the paddle, we change the x coordinate and y coordinate of the ball with the paddle. So let's do just like that. So basically this dot x equal this particular paddle on which the ball is dot x, and perhaps we should put it in the middle of the paddle plus width, half of the width. So something like that. And if we run it, all right, it's moving with the pedal, but the y just jumped arbitrarily on the screen because it's produced random initially. Let's see. Yep, the y is produced random initially. What we can do, we can also basically put the y as belonging to the paddle, and this one will be a little bit more difficult to figure out. So it's the pedal y. Let's just put it for the second just here. All right, so it's pedal y, we subtract the ball radius from it, and we should be good here. This dot r, yeah, this dot r. All right, but I think we are not in good shape if we are basically want to park the ball on the top pedal, because the hot surface of the top pedal, it's on the other side. It's here. It's not here. So okay, let's try to do that one. Let's just change the state. So basically the change to be 2, and if we run it, yep, the ball is parked on the upper surface. So so here what we can do, it's maybe we should pass also an argument to this function that the pedal is top or bottom, and if it's bottom, yeah, maybe we should do that. Is bottom or inversed, because the top paddle is inversed. So if it's inversed, the y is basically, yeah, maybe inversed. Let's say inversed, which will send a true in the second case. So for the bottom paddle is not inversed, it's false, and we're gonna send a true, an inverse flag if basically we try to park it on the top one. And if it's inversed, what we can do, we can well, first of all, we can just say here if inversed. We can take care of the first case, else this is the second case. Let's do that. Let's not correct it or adjust it in any way. Let's do just like this. So basically on the top pedal, this what y is pedal.y plus pedal.h plus this.r, because we're going in the other direction, right? We're adding the height and also adding the radius, and it looks correct. So the ball is parked on one of the pedals and works just fine, just like this. Let's put it on the bottom one, because we like starting from the bottom here. All right, it looks quite okay. We need now to launch the ball. We don't have any way to launch the ball. Let's see how can we launch the ball. Where did we interact with the keyboard? Okay, we interacted in the create paddle. Okay, so the paddle object is listening for the keyboard. Perhaps also the paddle object can launch the ball, like has a special power. The paddle is launching the ball, right? So the way we can do this one, we can also listen for the keyboard here, and we can use space to launch the ball. I don't know any constant for the space as mentioned last time, but we can use number 32, which is the key code for space. So if we are pressing the space, what we can do, yes, let's define a property, launching. This become true, launching become true. So pedal is launching. So let's see, have this property here, launching, and initially is false. The pedal is not launching, but if we are pressing the key down, launching becomes true. And now, okay, still okay. Of course, the space bar is not working because we are not doing anything with the launching. But now, if we are launching, we can change the state. So we are in this state, update on pedal. So we are on a pedal. We are here. We take care of moving the pedal. What else we can do here? We can also say if, so this is pedal basically. The pedal is launching. So we are checking if the launching property is true for that particular pedal. If that's the case, we can basically change the ball to be, we are inside the ball right here, yes. So this refers to the ball, and we'll make this state equals 0. All right, so let's say this state equals 0, and also let's make the pedal launching false, because we already launched the ball and we don't want to launch it continuously in a sense. So I think it's enough. Yeah, let's run it. Okay, space. All right, all right, all right. And I can play Pong. Oops, and I lost. And you know what? And I'm using, when I'm using the left and arrow keys, actually both pedals are moving. But let's use different keys, right? And maybe if we use different keys, perhaps left and arrow keys should move the bottom pedal, and perhaps Q and W. I'm looking here on my keyboard, looks like a top ones on the top row. Q and W maybe should move the top pedal. And if we do this, we can play with two players, right? We can have a friend on the same keyboard, we cram together on the same keyboard, and one is controlling the top pedal and one is controlling the bottom pedal, and we'll try to win the game. So let's see how we can do that thing. All right, so the program is a little bit is big, but you know, it's still, if we look at it to it in a minimized form, we still have one create pedal and one create ball. All right, maybe the pedals, when we are creating the pedals, we should also specify from outside, because we are sending the coordinates where to create the pedal. We should also specify the keys, what keys to use. So the bottom pedal should use basically, you can say left arrow and right arrow. So we are actually not hard coding the keys inside, but we are passing them from outside. And basically inside here we can say create pedal, first of all, should take also key left and key right, two variables. So we say if it's key down, key left, or if it's key down, key right. And now notice this time we don't put, and we didn't mention, but we are referring to key left and key right variables just like this, without this dot, because these are not properties of the object. They are these variables like the parameters of the function, so they are from outside world here. So just to make sure that is working correctly, I'm gonna use the same keys here. So if I'm doing this, okay, both are moving in the same way. So let's see what Q and W, what key codes they have. So we said JavaScript key codes. We said that they are, yeah, this site, it's really good at finding key codes of keystrokes in JavaScript. Apparently it's not working at this moment. All right, let me refresh it. Maybe it's working, maybe not. If not, we can just create our own small little test program to test for the key. But let's hope this one is working. So yeah, apparently it's not working. Oh, it appeared. No, it didn't. Perhaps it's still loading. What should be the key code for? Yeah, let's search another site. If not, we're gonna create our own examples to display it. Yep. Okay, no, this one is not working. Well, let's create our own example, shall we? Really quickly here, we go inside here, user input, keep pressed. Yeah, let's use keep pressed basically. Yeah. And, oh, I think we have already a sample here. Let's press Q. Should be 81 and 87. 81 and 87. Really good. So we have already an example, 81 and 87. So this one should be 81 and 87. Now, if we'll just leave them like that, maybe we'll not know. So let's say here, let's have to const key Q, it's 81, const key W is 87. So let's replace these constants here because it will be hard for us to remember in the future, right? So let's run the program. All right, I can move the bottom one independently and I can move also the top one. Now I'm a single player here, but imagine you can have tons of fun with a friend and you can control the pedals on from the same keyboard. This is how kids in the 80s used to play multiplayer games, just crammed together on the same computer. Lots of fun. All right, let me save it. And as last time, let's put a little bit of a nicer background here. I don't know, I'm not good at picking backgrounds and colors. We can make a space pong and have this. Well, let's use just the checkerboard one for the moment. Same as last time. I think we used the same one. We're gonna just place it here. Let's place it here. Let's run it. Yep. And now, of course, we can also make the paddle field, not have this black and white kind of colors. Let's color them a little bit, shall we? Of course we should. So paddle, when we are displaying here, perhaps we should fill it with a nice color. And what color is a paddle? Pong paddle. Dark salmon? Indian red, like coral, maybe a brown one or a green, or yeah, let's pick chocolate. This looks like an appropriate color. I drag and drop, but the editor just plays background here, so I'll just replace it with fill. Yeah, both fill and background use the same colors. So paddles are chocolate. Oh, and the ball is also chocolate. I don't like the ball to be this color, so when I'm displaying the ball here, let's fill it with, well, it can be white for the moment, or any other nice color. So we are launching it, and All right. And we lost it. So and what can we do right now? Right, we are almost ready with the game here, but still we need to basically, what else needs to be done? We need to keep score. We need to know the score of each player, basically, top player, bottom player, keep the score, and then switch the ball to the other paddle when one wins, when one loses, that kind of thing, right? So the way we can do that, we can have some global variables to keep score, or we can also have an object. Perhaps since we are talking about objects and functions, we can have an object game. So the game will have, basically will keep the score, and also the game maybe should check if the ball goes outside, and then change the ball to the other player, something like that. So yeah, something like that. So first of all, let's have a property on the ball here. If the ball goes outside, we can basically, outside can be top, bottom, similar to state, right? The ball can be inside, can be outside to the bottom, or can be outside to the to the top, right? So we can have that one as well, and then and then we can have the game object to basically keep state of these games. Yeah, so let's have that one as well, that variable, and perhaps after that we should wrap up. We should I don't intend to finish the game today because we have more lessons, and perhaps we should finish it in a different lesson. But for now, let's extend it just a little bit to give you a little bit more information if you want to extend the game on your own till next time. All right. So let's have this one ball, its state in motion. We can make use of the state, basically, same variable. So it's in motion inside the canvas, it's on bottom paddle, on top paddle, and let's see if it goes outside. Here, yeah, we can have also different states for the ball. It's outside on the top and outside on the bottom. So we can leverage the same property here, state. Let's add some more values to it. So can be 0 like that, 2 bottom paddle, can be top paddle, and can be let's think a little bit if it's necessary to keep the state of the ball going outside. Yeah, we can keep the state of that one, but let's see what we can do, because that would be necessary when we finish the game. I'm just thinking to wrap it up in an intermediate state for now. Check the bottom pedal here. If okay, let's check if the ball goes outside here. Yeah, we're gonna wrap it in this way for now. We don't keep score. If you want, you can. I think we kept score in the previous lesson, so you can merge with that one. Or if we didn't keep score, I don't remember. Just wait for the next lesson. For now, we're gonna just check this one. If the ball goes, if it's less than 0, meaning basically goes outside on that top margin, what we'll have to do, what we are doing is just we are resetting the ball. Basically, this dot state equal. Let's put it on the paddle of which player. So if it goes to the top, means that that one is losing. So the next one is serving. The one that is serving basically is 1 here, right? So let's just switch this one, and You can also have a like with an else if here, else if this dot y is greater than 600. Basically the ball left already the canvas to the bottom margin. Let's say this dot state equal to, should be the other pedal. Let's check this one. So all right, it's it's coming back. I'm launching it. Let's lose it on the bottom as well. Oops, and it's launching from the other one, but that one is in the state of launching, so should not be in the state of launching, and we should be good. So let's see, else if this dot y is less than 0, this dot state is 1, and yeah, well, I think we have the pedal. Let's not put them in state of launching. Why is launching? Why is launching? Because it's update, its state is 1, should be update on pedal, and basically when it's on the pedal should not be launching. Pedal launching should be false. Normally should be false. Let's just force it here for the moment. So this bottom pedal launching is false. Or this is basically, yeah, this is bottom pedal and this should be top. Although this one probably is not solving the problem. All right, if we leave it, yep. Oh, that one solved it. Somehow remained in the state of launching. Let's lose it on the top or bottom again. No action. Yep, it comes back on the top. Let's let the ball leave. All right, and comes on the top. And if we are losing to the top now, it comes on the bottom pedal. So seems correct here, right? So now all we have to do is just keep the score that we mentioned. We can have that game object, and we can see already that the that the balls are changing the pedal once it leaves the screen from one player to the other. But we won't finish it today, like we said, but feel free to finish it. You can also add some nice graphic, put some bold text here for the score on the bottom, on the top. You can put you know, some middle line like in Pong. You know, you're up to your imagination, right? So I'm gonna save this this mini game right now. Let's look at how many lines it has. Just 150 lines of code, not too many. It's still a mini game. As I mentioned, we plan to finish it in a future lesson, and actually not finish it in the current form, but we're gonna re-implement it again using new concepts. But if you want to finish it with the concepts that we just discussed today, it's nothing else than adding a score probably there, and you can just have fun with a friend. All right, so I hope that you enjoyed the today lesson about objects and functions inside objects. That was the topic. You learned about the this keyword to access inner members while inside the object, and we also took the opportunity to implement a mini Pong-like game in this lesson. So thank you for watching, and you know, happy coding, and see you next time.